This tutorial video is gonna just build a very basic Hello World application for Nostr using the Nostr Rust libraries. I've have the tutorial on the left-hand side and my IDE on the right-hand side. I'm just going to walk through all the steps that are laid out. You can find this tutorial at indykit.com/hello-nostr. And also on GitHub at github.com/nostrdevkit. Okay, so if you haven't had a chance to install Rust, go ahead and probably pause the video and do that. And then what I've done here on the right hand side is just created a new binary project with cargo new hello Nostr. And then I've opened that project in Visual Studio Code. So the first thing I'll do is just make sure that it runs okay. Can do that with cargo run. Hello world. Can also do that by building it first and running the binary directly from the release folder. Same thing. All right. So the first thing that we're going to do is generate a Nostr key pair. And although I don't recommend using a web tool to do that for your own account, we're going to do that just for the tutorial. So this site, nostr.rest, you can click at this blue button at the bottom, generate vanity key pair slow. I guess it defaults here to BE, which is fine. You can put something else in there if you want. And it quickly generates a public and private key pair for us. So what I'm going to do is copy the private key. I'm going to move over to my IDE and I'm going to create a constant and store the private key there as a string. So now we can close that. We've created the constant as it lays out here. The next thing we'll do is add Rust Nostr as a dependency. So for that, we'll go into the cargo file here, and under dependencies, Nostr SDK, and we need Tokyo, so we'll go ahead and do that while I'm in here. Okay. Now let's see, back at our main.rs file, we need to add the import statement at the top. And we'll also add, update the main function to be tagged with the Tokyo label and make it async and also return a result. So I'm just going to copy those and paste it over. Perfect. Okay. So the first step, first thing that we need to do here is load the private key variable into the keychain. So what I'm going to do is just copy this, come back into the main, paste it, and make that a little bit smaller here. So this is just reading the private key as a string into the secret key type, and then using the secret key type to create an instance of keys which will hold the public and the private key pair. So just to make sure that that's working appropriately, we'll go ahead and just print out the public key. I'm just going to copy that, drop it in here. I don't know if that's going to be too small. Okay, and so we'll save that in the IDE. We also need to import the from string. Let's see, I think that's okay. And so this is just a print line macro, hello Nostr, and then we grab the public key from the myKeys type and just print it out. So let's take a look. Actually, we're not going to run it with cargo run release. While that's compiling, let's see what's next. So the next thing that we're going to do is add the client type and add 2 relays, and then we'll connect to the client. I'm going to pause the video just while that finishes compiling. All right, we're done compiling. So now when we run it, you can see it will print out our public key. That's our hex public key. We'll talk more about key pairs in another tutorial. Okay, so next step is to add the client type with 2 relays, and then we'll connect to it. So we'll just copy this. Paste it into a couple, connect to a couple relays. And we will publish, instead of just printing this note, we'll store it into a variable, and then we will print it, and we'll also publish it to the relays. So we will, well, let's see here. We'll use the format macro. Okay. Actually, yeah, we're going to print out this event as well. It's actually the event ID that is returned from the publish text note function. Okay, so let's save this and let's see what happens. Okay, great. So it prints it out again, just like it did before. And then we are returned the event ID. Now the event ID is actually is a hash of the event itself. And we'll take a look at what the entire event is in just a minute. So the event ID, or the event, contains a timestamp of when it was published. So if I run this again, you'll notice that it's a separate event ID. This one starts 368B2. This one starts E0493. Even though it's the same user and it's the same text, That's because, again, the timestamp is in there, and anytime you change anything within a payload that gets hashed, the entire hash will change. So from that, we've created, with just a few lines of code, created a new message, created a new event, and published that to two separate relays. So what we'll do now is use the filter object, filter type to retrieve that event, or retrieve a new event that we create. Okay, so this filter is part of the Nostr SDK message subscription filter. So we'll copy that. Okay. Now we're going to put in a thread sleep here because this all happens so fast that if you publish the note, the relay may not have it available to be queried by the time that we get to the next line of code. So what we're going to do is just sleep for 1 second and make sure that the relay has enough time to turn it around, and then it'll be available for us. Okay, so time sleep. Now I think I'm going to have to add some dependencies here. Let's see what those are. I think if I compile it, it'll probably tell me what those need to be. Okay, so standard time duration is what we'll use. And then that might be the only one we need. Normally, and most of the time when you're developing here, you're not going to need to do any waits. We're just it's just because it's an odd tutorial. Here, let's try to compile that again. All right, standard thread sleep is the other one it looks like we need. Maybe we need Tokyo. No, it's time dots. Let's try a thread. Okay. It is just Tokyo time. All right. So that's gonna create our filter for the event ID that we just posted. It's gonna take a nap, and then we'll call into the client to retrieve the event. Okay, and then we'll just print that out. Print out the events that come back in the vector. All right, let's see if this works. So this structure here on the left, okay, that did build, all right. So now we'll go ahead and run it. Okay, perfect. So let's take a look at this. Okay, great. So we have our first printout. Then we have the return value from published text note that has the event ID. And then from our subscription, from our query that we submitted with the filter object, again, we filtered on just the event ID that we got back from published text note. but we asked to retrieve the entire event. So this has all the information associated with the event. Let's quickly touch on what some of these are. Again, the ID that I mentioned. There's the public key of the user, the created at timestamp, or the public key of the publisher, the created at timestamp, Unix time, number of seconds since 1970, or whatever it is, the kind of event, and this was a text note. There's a section for tags we'll go into in another tutorial, and the content. Again, that's the same content that we've seen several times now. And so one key part about Nostr is that, similar to Bitcoin, where you're signing transactions with your private key, with Nostr you sign events or messages with your private key. And so that signature gets stored and saved with that event. So anywhere that event goes, that signature goes, and it can be verified that, without a shadow of a doubt, the person that had possession of the private key that goes along with this public key signed this event, which, again, the event contains the message, the content, as well as the timestamp. So we know, beyond a shadow of a doubt, this person or whomever possessed this private key approved, agreed, or came up with that content as of that timestamp. Okay, so that's how you would retrieve the event based on just the event ID. That's going to be pretty rare, right? Because you typically don't know the event ID when a user's working with a social media platform. So luckily there are great filtering tools that are available. So we'll kind of go into this, go into filters in detail another time, but for now we'll just use the basic filter. We'll use the filter and just pass in the authors with using our public key, and it'll retrieve all the messages that we've submitted with this public key. So if we ran it multiple times, they'll all come back. And then for all of the other criteria, we're just going to pass in blanks or this none value, which could be used to further filter down the query, but we'll just get everything under this author for now. Okay, so what I'm going to do, for this prior filter, I'm just going to comment it out. We're going to leave our sleep under the author's parameter to this filter object for filter type. I'm passing in my key's public key. Okay. Just rebuilding, and now we'll run it. Okay, so same public key printed out at the beginning, posted a new, just one new event ID, posted one new event at the beginning of this program, and then it slept for a second, and then it put together this filter type to send back to the relays, to both relays, to retrieve the events that have been submitted by this particular user. So let's see how many events that we have. There's one. That's the first one that, well, I'm not sure the order, but that's 1, 2, 3. So that's interesting. I would have thought there would have been, okay, so let's take a look. I would have thought there would have been 4 because we posted 2 messages to 2 relays, and then we sent the filter to both relays, but what we got back is only 3 events. But if you take a closer look, there's the event ID of the first event, there's the same event ID coming from another one of the relays, and then here at the top, that's coming back from, that's our latest event that was submitted. So what that tells me is that one of the relays, I guess, didn't have enough time to turn that around and make that event available for query. So what we'll do is just, I'm curious, I want to go in and I'm going to take out the publish. And what we'll do is just query again. Now that it's been a minute or more, we'll query again and see if we get back 3 events or 4. I don't know what it's going to do, so. You know, using multiple relays is censorship resistance in action. You replicate the information across multiple relays, which are run by, each individual relay is run by a centralized party or a person, and that relay operator can choose who and what can be posted. So in order to retain our censorship resistance, we want to make sure that we are posting to multiple relays. Okay, so let's take a look. We'll scroll back up to the top here. Okay, so this first event, that's the one that starts with F22. So that's the second event that we submitted in this tutorial, followed by the 06D2. That's the first event we submitted. Okay, now we're getting 2 of these. So then the F22, that's again the second event, and the 06D2, the first event again. So in the results set, it's not necessarily sequenced by any particular method that we defined, but each of the events came back from each of the relays now. So in the last time that we ran it, the 1 second sleep just wasn't long enough for one of the relays, we don't know which one, for one of the relays to not be able to turn it around. Okay, and that's it for this tutorial. So what we've done is you should have been able to install the Rust toolchain following the instructions that were in the document in the tutorial. Submit an event, retrieve an event by the event ID. Also submit an event and retrieve all events from a particular publisher. So this code is in, if you want to run it yourself, it's in the Nostr dev kit, Hello Nostr repo.